Welcome to today's math class. Today we have this question before us. It's an exponential equation here, but we just have to be careful in solving this kind of challenge here. So I'm going to take you through the carefulness needed in solving this math challenge here. So if you welcome, this is Online Math TV. Let's go into today's challenge. So we have 4 to the power of x plus 25 to the power of x equals to 10 to the power of x plus 1. What is the value of x here that will satisfy this challenge? So we take our solution here first thing. All right, now if you look at this challenge, the left-hand side of the equation doesn't have a problem per se, but look at the right-hand side of this challenge. You just want to rewrite this side of this expression here. We know, according to the law of indices, which says that if you have your, take for instance, you have your a to the power of m plus n. This is equal to your a to the power of m times a to the power of n, right? Good. So if we make use of this, we can rewrite the right-hand side of the equation. And so this is going to give us 4 to the power of x plus 25 to the power of x equal to 10 to the power of x times 10 to the power of 1, which is divisible 1 here. Okay. Here we are having 4 to the power of x here and 25 to the power of x here. So what we do here now is easy. We are having 10 to the power of x here. So let's eliminate this 10 to the power of x here. And to do that, we divide by 10 to the power of x. So we're going to divide this side by 10 to the power of x. We equally divide this by 10 to the power of x. We equally divide this by 10 to the power of x. So this leaves the system. We are left with 10 here. All right? So let's go ahead and rewrite this out here now. Now, before then, look at this expression we have here now. Because another law says that if you have your a to the power of your m all over a to the power of, okay, now this must not necessarily be a, so let's take our b to the power of m. This is equal to, because the powers are the same, so this is going to give us a all over our b all raised to the power of m. So we're going to apply this law to this expression here. So we have here 4 all over 10 all raised to the power of x plus our 25 all over 10 all raised to the power of x. This is equal to, on this side, we're left with just 10. All right, look at this. If you look at the terms inside the bracket, you discover that something can go into 4 and 10 without remainder, and that is 2. And here, 25 here, 5 can go into 25 without remainder, and 5 can go into 10 without remainder. So if we split this down, so here it's going to give us 2 all over our 5 all raised to the power of x, then plus here is going to give us 5 all over 2 all raised to the power of x. This is equal to 10. Now let's look at this carefully. Look at the term we have in here and what we have in here. Here is 2 all over 5 and here is 5 all over 2. So we want to rewrite what we have inside this. I want to twist this up and bring this down. And so we apply another law again. Okay? The law of indices, which says that if you have your a, let's take a all over b all raised to the power of n. This is same thing as you move this up, bring this down. So this is going to give us b all over ra. They're all raised to, there will not be a minus attached to the exponent. And so I want to take this up, bring this down, then the power here will take a minus sign. So we're going to have here 2 all over 5 all raised to the power of x, then plus our 2 all over 5 all raised to the power of minus x equal to 10. Okay, so now let's look at this now. We still have a slight difference between this and this. Here it's having a minus sign, so we just have to eliminate this minus sign by introducing the reciprocal of this. In other words, we want to rewrite this. So this could be written as 2 all over 5 all raised to the power of x plus 1 all over 2 all over 5 all to the positive power of x. This is equals to 10. Okay? All right. So we now have what we have here, same thing we have here now. We can do a simple substitution here by bringing in another variable. So from here, let's say here, let let's say, let whatever we have here, which is 2 all over 5, all raised to the power of x, be equal to, let's pick m this time around. So wherever we see this expression, let's put in m there. So this now implies our m there plus 1 all over m equal to 10. Do away with this m at the denominator. So we multiply through by m. And so this is going to give us m times m close bracket there plus 1 all over m times m close bracket equal to 10 times m. Let's put this in bracket also. So what happened is this leave the system. So we're going to have this m to the power of 2 there plus our 1 equal to 10m. What kind of equation is it? This is a quadratic equation. So we move this to the side of the expression. So this is going to give us m to the power of 2 there minus 10m plus 1 equal to, let's put our 1 here, plus 1 there equal to 0. So how do we solve this quadratic equation? We want to apply the formula method. We all know the formula method, which says that m equal to minus b plus minus the square root of b squared minus 4ac all over 2a, right? So let's put it here. So using the formula method, where is the formula? The formula says that our m will now be equal to minus b plus minus the square root of our b squared minus 4ac everything all over 2a. All we just need to do is to bring the value of a, b, and c so that we can confidently substitute them into the formula, simplify, and get our answer. So we know where our a is the coefficient of m squared, which is 1, and our b is the coefficient of just m, which is minus 10, and our c, let's put it here, c is equal to positive 1. So substituting, this now implies that our m will now be equal to, look at our b here, so we have minus bracket minus 10 close bracket plus minus the square root of our minus 10 r to the power of 2 minus 4 times, what is our a is 1, yeah, 1 times another 1, okay, so everything all over 2 times 1. Easy. So minus times minus gives us plus. So we're going to have m now be equal to our 10 there plus minus square root minus 10 to the power of 2 will give us 100 minus our 4 everything all over 2. All right, so let's continue again. We can carry out the subtraction here now. So this is going to give us our m will now be equal to 10 plus minus the square root of, if we take away 4 from 100, that will give us 96. So we have here 96 everything all over 2. So we have m will now be equal to 10 plus minus the square root of, now we can break 96 down into a perfect square and an irrational number. And so 96 can be expressed as 16 times 6. So we're going to have here our 16 times 6 all over 2. 16 is a perfect square, as we all know, and that will give us 4. So this will end up giving us 10 plus minus 4 into the square root of 6 all over 2. Look at the number we have at the denominator is 2. So let's factor out 2 from here, because 2 can go into 10 and 2 can go into 4 without remainder. So if we factor out 2, this is going to give us 2 into 10 will give us our 5 plus minus 2 into 4 will give us 2, then into the square root of 6 close bracket all over 2. So what happened? These 2 goes with these 2 here. So we now end up having our m will now be equal to our 5 plus minus 2 root 6. Easy. But here we have 2 solutions from here now. In other words, we have m1 and m2. And so we're going to have this to be m1 is equals to 5 plus 2 root 6. And our m2 is equal to 5 minus 2 root 6. All right, so now let's keep these 2 answers here now. These answers will enable us to solve for the actual variable in this question, because at first, look at what we have here. X is the variable we have here. So how do we get the variable? We recall where we said let 2 all over 5 raised to the power of x be equal to our m. And so if we look at the 2-case scenario here, we know that m must be greater than 0. And so here, we have this greater than 0. This is also greater than 0. So the two solutions are going to be useful in solving for our x here. So let's continue on this side of the board again. All right. So again, we want to record this expression we have here now. So from here, we're going to have our 2 all over 5 all to the power of our x will now be our m1, which is what we have here. So let's just put in what we have there, 5 plus 2 root 6. It is easy. What to do here is easy. All we just need to do is to log both sides of the equation. So we're going to take log to base 10. Okay, we could as well use log to base 2 all over 5. Okay, but let's go gradually. Let's take log to base 10. So this is going to give us here our log 2 all over 5 all raised to the power of x base 10. This is equal to the log of our 5 plus 2 root 6 close bracket of base 10. Now, according to the law of logarithm, we say that if you have your log, your m to the power of p, move this to this side, okay, to give us here log our p times log our m here. All right, so this will give us this. So if we apply this law here, then we're going to move this down to this side here. So we're going to end up having x times our log our 2 all over 5 bracket base 10. This is equal to our log bracket 5 plus 2 root 6 close bracket base 10. Now, if you look at our x now, x has positioned itself in such a way that it can stand alone. How? By eliminating what we have here, which is log 2 base, log 2 all over 5 base 10, right? So this is going to give us here, we divide through by log our 2 all over 5, yes, base 10. We equally divide this side by our log 2 all over 5 into base 10. So this leaves the system. We now have our x standing alone. So we have our x is equal to, now look at this. We can apply the division law of logarithm to this expression. But before that, let's write this out well first. So this is going to give us our log bracket 5 plus 2 root 6 close bracket base 10 all over our log our 2 all over 5 into base 10. Now take a critical look at this expression we have here now. We can apply the division law of logarithm. What does it say? It says that if you have your log, your m, then all over n in bracket here, this will give us here our log, your m, then minus log, your n, right? Okay, so if we apply this to this, what will become of our expression here? So let's put it down here. From there, this is going to give us, therefore, our x1 will now be equal to, look at what we have here. So we have log our 5 close bracket plus 2 root 6 close bracket base 10 all over our log 2 base 10, then minus our log 5 base 10. So this is our x1. Now, again, remember, we have our S2, okay, because the first one we just saw for now is for this. So for our expression here, so we're going to have the same thing, which is we know that 2 all over 5 all to the power of x will now be equal to our 5 minus 2 root 6 for our case 2. Okay, this is our case 2, right? This is our case 2. Let's indicate it. So this is our case 2. If you follow this same procedure down again, we're going to have our x2. Therefore, will now be equal to what? Our log of 5 bracket open plus, minus this time around. We're going to take minus our 2 root 6 close bracket base 10 all over our log 2, then minus our log 5. is 10, this 10. So this is our second root that satisfies the original equation. Meanwhile, this is our first root that satisfies the original equation. All right. So this brings us to the end of this math class. If you learned something from this video tutorial, then do not forget to give this video a thumbs up. So if you've not subscribed, this is Online Maths TV. Do us that favor by subscribing. And when you subscribe, turn on the bell notification button so that you get notified whenever we release an amazing video like the one you just watched right now, even more better than the one you just watched now. Thanks for watching Online Maths TV content. We love you beyond measure. Thanks once again. Bye. But until we meet you in our next class, keep winning. Bye for now.